In this lesson, we'll explore the 2D dynamic toolpaths and how to create them on this part. I've opened the part called 2D Mill Fixture Program, and as you can tell, we have a mill default machine selected with no toolpaths on it. If we go to the Planes Manager, you'll notice that there's a few planes. One of them in particular is called Fixture Plate Plane. That's the current WCS that we'll be using for this part. If you go back to the Toolpaths Manager and click on Stock Setup, you notice that there is stock already defined. So it's about 7.8 by 7.8 by about 1.6 in Z. However, it's not displayed, so I can simply click on the display option, click OK, and now that stock is displayed. Let's start by creating a dynamic toolpath. I'll go up to the 2D group in the Toolpaths tab and click on Dynamic. And as you saw before, this is where we select our chains for machining, as well as our avoidance regions and so forth. If I don't select any geometry and click on Preview Chains, you'll notice by default, it accepts the entire area as my machining region. So this is a good start, because I don't have to select any geometry. However, looking at it from this angle, you'll notice that we are still going to be hitting these islands. So I'm going to go right into the avoidance regions and pick these avoidance regions. That one there, that one, and that one. Now when I click OK and then hit Preview, you'll notice that it is in fact machining out that area, however it's avoiding those three islands. And finally, if I want to machine this area coming in from the outside, I can choose From Outside and then hit Preview Change one last time. You'll notice that my preview updates. And now I see the blue area as my motion region. So this is where the tool can enter and exit the material. So at this point, we don't have a machining region set up, but we do have an avoidance region. And those avoidance regions are these three right here. So I'm going to click OK and look at my parameters for this toolpath. So as we saw before, we can change our strategy right here now that we're in our toolpath, and we can also preview the change again. If I go to the Tool tab, you'll notice that there's a bunch of tools here. That's because we've pre-populated this particular file with these tools. I'm going to choose tool number 10, and I will call this Dynamic Mill Roughing. One of the things I can also do here is turn on this option called RCTF, and this stands for Radial Chip Thinning Factor. Radial chip thinning is the process by which you're trying to maintain the amount of material you're taking off with an end mill. Ideally, you want to use more of the edge of the tool to remove material. So you can do this two ways. You can either take a bigger or smaller bite of material, which means a bigger or smaller step over, or you can move the end mill faster or slower, thereby taking a bigger or smaller bite and affecting your chip load. The chip thinning is this second option, where based on your step over, your feed will change to result in a desired chip thickness. Once I turn it on, you'll notice that my feed rate and my spindle speed gray out. In other words, they're not something that I can change right now, because they're based on other options such as my feed per tooth and my surface feed per minute. This radial chip thinning factor is based on a 50% step over or less. So if you notice right now, my feed rate is 7.4. If I go to my cut parameters and I change my step over to, let's just say, 45%, and then go back to the tool, now the 7.4 is now 6.4. And again, if I go back to my cut parameters and change this to, let's just say something drastic like 5%, and go back to the tool, you'll notice that the feed rate is much higher. However, these calculations only work up to 50%. So if I go in and change this to, let's just say 80%, and go back to tool, you'll see the feed rate of 6.4. It maxes out at 50% based on the calculation. So this 6.4 is going to be the same value at 80% and also 50%. For now, let's go back and change our cut parameters to around 25%. And I'm going to change my stock to leave on floors to be 0. However, we will stay away from the walls by 50 thousandths. Let's go to the depth cut section, and we're going to add depth cuts because this is a pretty large depth to be making in one pass. So we'll change the depth cut to 0.35. Now the reason this says max rough step is because let's just say we were going 1 inch total depth. 0.35 cannot go into 1 inch evenly. So it will figure the math out to make equal depth cuts, but it cannot go above 0.35 deep. For our entry motion, I'm going to make sure helix is turned on. However, this is a good opportunity to look at some other options. And again, if you're entering from outside of the part, you might be entering using the side of your tool instead of plunging. So there are options for creating different shaped helixes for the first pass based on geometry and then followed by full medial burial. You can also identify the overall profile of the shape, and Mastercam will enter using that profile. Or you could even draw a custom chain and have the tool follow that chain into the part. For now, we'll keep it at helix only with the default values. Moving on to linking parameters, let's take a look at these values specifically. If you recall, for our geometry, we did not select any to machine, which is why it grabbed the entire shape there. So the depth here needs to be defined. So I'm going to click on depth and go right to this value here. So it sees it as minus 0.61. My top of stock will be set to 0 absolute, which makes sense because that's this value right here. My feed plane will be 0.1 above that. And my retract will be set to 0.25. And let's do incremental for now. And as far as the clearance goes, let's turn on the clearance plane and make this 0.5. So with these values, if I click OK, our toolpath will be calculated, and then we can explore the results of that toolpath. So a lot of times what I'll do is I'll go right into backplot so I can see how the toolpath starts. It looks like it starts from the outside, and I hit the letter S key so I can see how it enters into the part. Now it looks good, it's not plunging into material. And then I'll hit play to see how this thing actually cuts through the material. And you can see it's navigating around the islands here. At this point I hit stop, and you'll notice that I have an interesting move right here. Once the tool path is done with this depth cut, it retracts up, and it comes through, and it actually violates this area right here. Now why is that? Well, this is a retract move. And what we can do is zoom in here and actually click on a toolpath, and the tool will go right there. You can only do that while you're in backplot. And then if we look at the steps here, let me back up a few. Okay, so if I step through this and you look at, notice my Z value right here, I'm at minus 0.3051. So if I step through this, it pulls up, and now it's at 0.0551. Well, that's 0.25 above where it was. That happens to be our retract value, but our retract value is set to incremental, so it will retract 0.25 from where it is. So let's go back and make a change to that in such a way where it'll retract up absolute, so it always retracts to 0.25 positive above 0. So now when we click OK and recalculate, you'll notice that retract move should come way up, and it'll clear that little boss right there, which is exactly what we wanted. So when you see things like this, you can adjust the toolpath to make it more safe and more efficient as well. Now obviously we could adjust this retract so it's not as high, which might give us some more efficiency in the toolpath motion, but for now this is a safe bet.